This equilibrium problem is multi-step and involves LeChatelier's principle. But first, let's set up our ice chart for H2 plus I2 producing 2HI and write the expression for Kc, which will be equal to the concentration of HI squared over the concentration of H2 and the concentration of I2. You should notice that we're not given a value for Kc. However, we are told about the concentrations present at equilibrium in the problem. So we can calculate our equilibrium constant. The concentration of HI at equilibrium is given for 0.490 molar. And for H2 is 0.080 molar. And for I2 is 0.060 molar. So Kc will equal 50. Now we've disturbed equilibrium by adding 0.300 moles of HI. So let's set up our ice chart so that we can solve for the concentrations when equilibrium is reestablished. So our H2 and our O2 haven't changed. We still have 0.080 molar H2 and 0.060 molar of I2. Adding 0.300 moles of HI will give us 0.790 molar HI. To determine which direction the reaction will shift, we can calculate the reaction quotient, or QC, by plugging in our new concentrations, 0.790 for HI, and keeping the H2 and I2 the same, and we get QC equal to 130. We can compare the values of QC and KC. QC is 130, KC is 50, so QC is greater than KC, which tells us that we should shift to the left or towards the reactants, meaning that the concentration of HI will decrease, minus 2x, and I2 and H2 will increase by x. E will be our I plus C. To solve for x, we plug in our equilibrium concentrations into the expression for Kc. Kc is 50, and that will equal 0.790 minus 2x squared for the concentration of HI over 0.080 plus x, concentration of H2, times 0.060 plus x, which is the concentration of I2. To solve this quadratic equation, we have to get our quadratic in the form of ax squared plus bx plus c equals 0. And to do that, we'll have to begin with foiling. So we need to FOIL the top and the bottom of the fraction. So foiling the top, we end up with 0.6241 minus 3.16x plus 4x squared. And foiling the bottom gives us 0.0048 plus 0.14x plus x squared. We have to move the denominator to the left side of the equation. And distribute. So we get 0.24 plus 7x plus 50x squared on the left side. And now I'm going to move everything on the left side to the right side. So we get 0 equals 0.3841 minus 10.16x minus 46x squared. To solve for x, you can use the quadratic formula, or you can plug in the values of a, b, and c into a quadratic solver, and we get two answers. X will equal negative 0.254 and x equals 0.0329. Since we know that concentration cannot be negative, we can eliminate the x1 value and plug in the value of x2 into our equilibrium concentrations. So the concentration of HI at equilibrium will be 0.790 minus 2 times our value of x, 0.0329, which equals 0.724 molar. The concentration of H2 will be 0.080 plus the value of x, 0.0329, which is 0.113 molar. And the concentration of I2 will be 0.060 plus the value of x, 0.0329, which is 0.0929 molar.